this image, you can see the larvae. So that's about the similar size of an egg, Varroa egg. We've got the proto-nymph, the adult male on the top right there, and the adult male never, I guess the carapace, the kind of shell of the Varroa male, never hardens like the female might. So it's very rare that you'll see him unless you're actively uncapping brood. So if you're doing your drone uncapping to find Varroa, that's an instance where you might find one of those little fellas. And on the bottom, you've got the immature female, the female deutonymph, which is a very soft shell, so she hasn't, the carapace, that shell hasn't hardened, she's not matured yet. And the bottom left is our adult female. So that's the mite you're most likely to see. That's the stage you're most likely to see, because when you're looking for Varroa, you're looking for that adult female mite, which is on adult bees. So she can be found in capped brood cells as well as on adult bees, and that's the stage we look at when we're assessing, do we have mites, through our alcohol washing, soapy water wash, sugar shake, or drone uncapping, or looking at debris on a ventilated bottom board where we've got a tray or a sticky mat. So we'll get into these methods, right? I'll talk about 5 methods for assessing Varroa tolerance or resistance, and this is one that you all might be doing already. So mite population growth. We're looking at how does that colony manage that mite population over time? And hopefully you've all had a chance at those monitoring methods, alcohol wash, sugar shake, soapy water wash, and you've been able to see those adult, I mean, we don't hope to see this, but eventually you will, and find those adult mites, female mites that have been washed off those nurse bees that you're harvesting. So you're getting your 300 bee sample from the brood nest, because we want to target nurse bees, which are most likely to have those mites on their underside between the segments, because Varroa is feeding there, typically on the abdomen of adult bees. So with this method, you want to record that over time. So you want some things in place. You want to know which hive am I selecting from. So you want to identify your hives 1 through 50, or, you know, Queen Cleopatra, Queen Beyonce, like you want to know, what her levels are over time. And this is an assessment that's accessible for everybody. You're doing it anyways, and you want to pick your times of the season when you don't have too low a Varroa level to get any meaningful data. So if you've just put in, for example, a synthetic miticide or a non-synthetic miticide, you wouldn't, I suppose you potentially would go back right after you remove that miticide to check that it worked, but that level right afterwards wouldn't necessarily tell you much about mite population growth. You'd want to allow the hives some time for those levels to build up again, so you can say, okay, this one is suppressing it versus this one. Varroa sensitive hygiene, that's another trait, and in the scientific and queen breeding community, there's a couple traits that are kind of used interchangeably, the terminology. Varroa sensitive hygiene, or VSH, not VHS, is one of them. MNR, mite non-reproduction, and suppressed mite reproduction. Those 3 can be used interchangeably, and I guess I'll just set the scene with folks that we're still learning about all these tools that the bees have themselves to suppress or reduce Varroa populations. So there's advances still to be made. There's knowledge out there that we'll be discovering in Australia as we look into these traits about how our bees potentially can suppress those levels. So with VSH, Varroa sensitive hygiene, bees are uncapping the cells that they sense or suspect something's off inside. You might see this yourself with chalk brood or with sac brood, different bee viruses or pathogens in your brood nest. And what they do when they uncap that cell is they're disrupting Varroa's reproduction. Varroa is super protected under that capped cell. And anytime that capping is removed, that perfectly humid protected environment is changed drastically. So if they uncap it when the female is in this immature stage, she will dry out and die. So she will not successfully mature into an adult that can be reproductive. So these images show the immature female mite up the top and another immature female mite on that drone abdomen there. So she's just starting to get coloration around the outside of that shell, that carapace there. Another trait, we've got cell uncapping and recapping. So this is a trait that VSH bees can have, one of them. And what a queen breeder would look for is they'd get their scope out, microscope, and they'd harvest some frames to look specifically at individual cappings and to see, is there evidence that the bees have removed that capping? And sometimes they recap it. So remove the capping, that disrupts the Varroa mites' development, and some of them then recap it, as you can see in the top left there. So they've removed that wax and silken spun capping, and then another bee's come back and replace that capping. Varroa Development Officer Simon Phillips took this photo, which shows a little bit of uncapping in the field, which can also happen in really highly Varroa infested colonies. So there's a bit of a tipping point as to when that behavior happens, whether it's too far gone for that colony. And again, that recapping, it disrupts the maturity and the reproduction of the Varroa in the cell. So if it's uncapped, that mature female mite that has been laying those eggs, she'll bugger off to another cell. That's what she's doing. And then any immatures will dry up and die. Another trait we've got is suppressed mite reproduction. Science has also described this as mite non-reproduction. So this can include Varroa-sensitive hygiene traits, and also Varroa potentially not receiving some key signals from the brood itself as it develops. There's still a lot to know about these traits, so over time we might find different chemical cues in the bees that are disrupting Varroa's situation normal reproduction behavior. So in these images, we've got the male mite in the top left, the mature female mite up in the middle, and then that larval stage in the bottom. So that tiny little, kind of cute looking, maybe, cute larvae in the bottom is in the V of a cell, and you can see a little bit of Varroa feces. That's what that little bit of white is. So if you're doing uncapping, or you see, open brood that's hatched, have a look for that sign, that fecal deposit of the mites, because they have a bit of a latrine that they like to, defecate in a certain area. So that's a telltale sign. With VSH or SMR, suppressed mite reproduction, we're looking for particular stages of the brood so that we can see, okay, are my bees suppressing reproduction or not? And this is a chart that's freely available at beebreeding.net. There's a lot of breeding programs in Europe that look specifically for VSH traits or suppressed mite reproduction traits, and they're harvesting frames from colonies potentially that either have, in the case of VSH, I'll start over. So suppressed mite reproduction or mite non-reproduction, they are bringing frames in from those colonies, and they're uncapping a worker brood. This is specifically looked at in worker brood compared to drone brood. And they're looking at these particular stages of development of the worker brood and asking, okay, what Varroa is present in these cells? If it's just our founder female, if there's only one adult female in there, nobody else, that means she hasn't successfully laid that first egg, which will be a male, and she hasn't successfully laid any subsequent eggs, which become female, typically. So if there's only one founder female, that's a good sign for a breeder selecting for these traits. If there's only a male, that's also a good sign. That means she's successfully laid a male, but she hasn't successfully laid any other eggs. So these are the kind of things that breeders selecting for suppressed mite reproduction or mite non-reproduction are looking for. With Varroa-sensitive hygiene, that is a different kettle of fish. You've got your Harbo assay, which I encourage you guys to look into. And with that assay, they look for those traits in terms of uncapping 100 or 200 cells of of worker brood and seeing what's in them towards the autumn. So when they know that that bee population and the mite population is at a bit of a tipping point where the mite population is reaching its peak in a stable situation. The last trait I'll talk about before mite population growth again is our grooming and mite biting traits. These ones are pretty fun to think about, really, that the bees are kind of at war, biting legs off, biting mouth parts off of the Varroa mite, and we can look for this evidence with our screen bottom boards. So we need to make sure that we're controlling ants, because ants love to eat Varroa mites on a tray under a ventilated bottom board. And what we're looking for is mites that show some damage that the bees have done to them. So the top left, we've got a mite that's got all her legs. She's got 8 legs, and those ones are all intact and healthy. And then below her, on the bottom left, is a mite that's got some of her legs chewed off. So that would be an instance where you could say, okay, maybe the bees have a little bit of this mite biting behavior, if you see that. And on the right-hand side is also mite biting. So we can see the shell, or the carapace, as it's called, for this female mite has been bitten and it's cracked. And so any of this damage to the legs, the mouth parts, the carapace, that is a mortal wound to that Varroa, and it will die as a result of that. So beekeepers selecting for this trait will have ventilated bottom boards with a screen underneath, and then a tray or a sticky mat that they periodically check and assess these mites with a microscope. So with these 5 methods, you do need a dissecting microscope for 4 out of the 5, but our mite population growth, you don't need a microscope. You can just assess those levels with the naked eye. There's a lot of info on these traits already existing. Australian researchers have published this report, Resilient Beekeeping in the Face of Varroa. AgriFutures is our research and development corporation that uses honey levy funds from our commercial beekeepers for important research to Australian beekeepers. So I encourage you, if you're interested in these traits, to read this report, because it's got a whole lot of information, additionally from breeders that have been dealing with Varroa for decades overseas. So this is freely available online, and you can download it any day of the week, or you can purchase a hard copy from AgriFutures online. So they cover more traits in this report, but the ones we've focused on today are that mite population growth, which you can do using your alcohol wash, soapy water wash, or sugar shake. Varroa-sensitive hygiene is using a dissecting scope and pinpointing a specific age of worker brood to look for those traits. Cell uncapping and recapping also involves a dissecting microscope and having a very close look at the capped cell cappings of that worker brood to see, is it uncapped, or is there evidence that it's been uncapped and recapped? Or suppressed mite reproduction. We're looking under capped worker brood again, specific age range to see, has she successfully laid an egg, the Varroa female? Has she successfully laid a male and no females? And that's also interchangeably called mite non-reproduction. And then our grooming and mite biting, that research predominantly has come from Purdue University in the States. So if you're interested in that one, check out Purdue University's work on that. I want to focus a bit more on mite infestation over time, because that's an easy one we can all get our heads around. So when we have Varroa mite established in an area, there's a predictable curve of that population increase and decrease. Around New South Wales, we're seeing a variety of different cases in terms of Varroa levels and reinfestation and how Varroa populations increase after treatment. So, for example, in the Newcastle area, in the Sydney Basin, we're seeing high rates of reinfestation. We've got case studies that Emily Nordyke will talk about later today, where a beekeeper, for example, has treated with Varroa. 4 weeks later, so they've treated with Varroa, we'll start there. After the 6 to 8 week treatment period, they've removed the Varroa and found they've got 0 mites in an alcohol wash. They do their alcohol wash 4 weeks later, and they're at treatment threshold again. And so they've tried Apigard as well, so they're trying different methods and finding that in certain Sydney Basin areas, reinfestation in the surrounding environment is high. It's an intense infestation pressure. In some of our rural landscapes or open woodland where there's fewer feral bees and there's also fewer managed bees, we're finding there's a slower, generally speaking, slower reinfestation to that treatment threshold. So that's something we need to think about if we're thinking about selecting for Varroa resistance. For this early stage of Varroa establishment in Australia, we'll be working hard just to keep our bees alive. But as you learn about your environment and your Varroa infestation kind of habits in your different apiary environments, you can potentially start tracking what's my environmental difference between this apiary site to this apiary site, and then tease out some trends potentially between your hives. We don't want to select for anything in isolation, so if we only select for honey production, we might have some other traits that are not that ideal for us. The same thing goes for Varroa resistance and tolerance. So Aussie beekeepers, my colleague Nadine and I surveyed queen breeders, honey producers, and these were the traits that they found most important. This is from our Plan B beekeeper surveys, which is reported online and you can check out if you really want to dive into it. But I stress this because if we select for one thing only, we run the risk of other traits falling away. Honey production is a really highly heritable trait, meaning you get quick payoff if you're selecting for this trait. Production traits are typically highly heritable and easier to select for than fertility or pest and disease traits. So I'd stress beekeepers, focus on your top 3 traits that you want in your operation. There's some other key success points that you need to think of, and those ones are recording your hive identification and the pedigree of that hive. So if you know that your hives are all sister queens, that's variation you've taken out. If you have queens that are not that related, that will provide, I suppose, some valuable information. It's valuable to know the relatedness of your queens because that can tell you a little about the Varroa tolerance or resistance expression that you're thinking of or that you're seeing. So in the bottom middle, this is commercial queen breeder Casey Cooper's hives, the green load. So this particular apiary, he labels all those hives and all their supers with specific colored cleats. And every hive has a set of honey supers that only go back to that hive. And that's how over the decades he's managed a barrier system to keep track of his AFB. If he gets it, he can say, okay, supers from hive 77, they've only gone to hive 77. So if that one, I find a cell of AFB in, I can just earmark all those supers to irradiate, and they've never gone on any other hive. That's real, the best practice, I suppose. And because his hives are all labeled, if he's selecting for temperament, honey production, it's really easy for him to go back and not get confused to say, okay, I've harvested 3 supers or 4 to 5 ideal supers from this double brood nest box in the season. He can accurately go back and say, these were my top producers and they were from loads, green load, blue load, pink load. You can think of it in a number of ways. Tracking pedigree is important so that you can say, okay, I've got one apiary site, I've got queens from breeder A and I've got queens from breeder B. They're all selected for in the same environment, so you've controlled for that. Then you can look over time to see what's the difference in production or Varroa tolerance between these two queens in the one environment. Record keeping, I think, will be touched on throughout presentations today, and that's critical that you're able to take accurate records back to specific hives, not just for queen breeding, but just for Varroa management. So you want to make sure, as you're tracking your mite population growth, that you know what hives you have alcohol washed, and then the next time you visit, you might, if you're not queen breeding, you're just managing mites, you might go to different hives so that you're making sure there's not a spike potentially that is going unawares. So if you're looking to get into queen breeding, we've developed standardized definitions for all the traits that Australian beekeepers told us they value in their population, and that's in our free-to-download Plan B breeding manual on the AgriFutures website. It fleshes out all these topics that I've pretty much whirled through here in terms of hive identification, queen pedigree tracking. It's got different spreadsheets and things that'll help you track this information, and different scoring methods you can consider. Okay, if I wanted to select for honey, how would I go about it? We talk about either weighing honey as the most direct and accurate way to assess your honey production across your hives, or scoring for honey on a 1 to 5 scale. Everything's a 1 to 5 scale, from honey to chalk brood, Varroa population growth. That one is a specific one with your mite numbers over time. And to close out, I suppose, I'll just point you guys back to our varroa.org.au new website. So this one's got information on training upcoming, how to monitor in your hives, how to report and access the heat map, and our different management fact sheets, which we've got some of those available at the Tocal shop just out in the hallway here. So with our Varroa management program in the transition to management, we've got all the resources free to download on this website. So if you've attended a workshop through the transition to management, that workbook that Kelly Lease, Mark Page, myself, and our colleagues here at Tocal have developed will be free to download soon, and recommend that you guys visit our website if you haven't already. I suppose to close up before questions, I'll just remind folks that if you've attended a workshop and gotten a record-keeping workbook from us, or if some of you haven't had a chance to attend a workshop but are a registered beekeeper, you're welcome to pick one of those up for free from our bookstore today. And we'll slide some fact sheets in there as well about how to interpret miticide labels, permits, Varroa management, and Varroa biology in there. So recommend you guys check out our bookstore out there, and thank you again so much for coming back to our face-to-face Beekeepers Field Day.